Assalamu alaikum wa rahmatullahi wa barakatuh. My dear IGCSE students, a new paper, October-November 24, paper 42. Question 1. A rocket has an initial mass of 7.4 times 10 power 6 kilogram. Calculate the initial weight of the rocket. The weight equals mg, mass times gravity. Mass 7.4 times 10 power 6, gravity 9.8, 72520,000, and unit here for the weight Newton. Approximate this number 7.3 times 10 power 3, 6 and 1, 7, 10 power 7 Newton. Define in words the term weight. Weight is the force of gravity acts on an object. Figure 1.1 shows a part of a speed-time graph for a rocket as it leaves the ground and travels into space. Describe the motion of the rocket from O to A. From O to E, as you see here, the speed increases with a curve. A curve here means the acceleration itself increases. So acceleration increases. From A to B, speed also increases, but in a straight line. So it shows that the acceleration is constant. Draw a tangent to the graph at time equals 400 and use this to calculate the acceleration of the rocket at this time. Show your work. Well, acceleration equals the gradient of the tangent. So at this point 400, we will draw a line here, and this line intersect with the curve in this point. From this point we will draw the tangent. Tangent is a straight line that touches the curve without intersecting it. So it looks like this. From the tangent we will draw triangle. Let's find this points here of the hypotenuse. This point you find coordinates at 310. This is for x, and for y it's about 2000, and for this point it's x about 560, and for y 7400. Now we can find the gradient. A acceleration equals the gradient delta y over delta x. Delta y here 7400 minus 2400, and delta x 560 minus 310. We find about 20, and the unit of acceleration meter per second square. Final answer will be also 20 meter per second square. Rockets are used to launch satellites into space. When satellite is released, the rocket returns to the Earth. Explain in terms of the forces while the rocket reaches terminal velocity as it travels through the atmosphere back to the Earth. Well, as the rocket falls, its speed increases, so the air resistance also increases until the upward force of the air resistance becomes equal to the downward force of the weight. So the resultant force becomes 0. So acceleration equals also 0. So the speed becomes constant, which is the terminal velocity. Figure 2.1 shows a golf about hit a golf ball with a golf club. The initial momentum of the golf ball is 0. Define momentum. Momentum is the product of mass and velocity of the object. The golf club is in contact with the ball for 5 times 10 power negative 4 seconds. The velocity of the golf ball as it leaves the golf club is 41 meters per second. The golf ball has mass of 0.046 kilogram. Calculate the impulse. Impulse I equals delta B, change in momentum. So delta V, which equals M delta V, change in velocity. The mass is 0.046, this is kilogram, times the change in velocity. The velocity was 0 and becomes 41, so the change is 41, equals 1.886, and the unit here, the unit of mass and velocity, kilogram for the mass, velocity meter per second. By approximating this number and the final answer, so it becomes 1.9 and the unit kilogram meter per second. Calculate the force applied to the ball by the golf club. We know that the impulse equals the force times time. So force equals impulse divided by time. Impulse we calculated 1.9 and the time we said 5 here times 10 power negative 4 equals 3800, and the unit of force, of course, Newton. Final answer is the same number, 3800 Newton. State two energy resources for which radiation from the sun is the main source of energy, like wind energy, fossil fuel, biofuel, solar panels. A wind turbine is used to generate electricity. The useful output from the turbine in 1 second is 6,000 joules. The kinetic energy of the wind hitting the turbine is 1 second. In 1 second is 11,000 joules. The velocity of the wind hitting the turbine is 6.3 meters per second. Show that the mass of the air hitting the turbine each second is approximately 550 kilogram. Well, kinetic energy equals half mv squared. So from this equation, we need to adjust this equation to find the mass. So mass equals, send half to the other side, 2 kinetic energy divided by v squared. It equals 2 times kinetic energy, as it's written here, 11,000, and for the speed of the wind is 6.3 square. It equals 554.3 kilogram, which is almost about 550 kilogram. Calculate the efficiency of the turbine. You may assume that all kinetic energy stored in the wind is transferred to the turbine. Write equation of efficiency. Efficiency equals useful output energy divided by the total input energy times 100. So it equals, efficiency equals useful output energy is, as written here, 6,000 joules, and the total input energy, which is the kinetic energy, 11,000 joules times 100, it equals about 55%. Final answer, 55%. Tidal energy and wind energy are both renewable energy resources. Suggest one reason why tidal energy is a more useful energy resource than wind energy. Ignore the cost of construction and maintenance. Tides are more reliable because it follows a regular pattern, while wind changes all the time. The figure 4.1 shows a pressure cooker on an electric heating element. The cooker has a light fitting lid. The pressure cooker is half full of water as the water is heated. Some heat water evaporates before the water boils. Describe two differences between evaporation and boil of the water in the cooker. Occurs at a certain temperature and you can write evaporation is affected by surface area, humidity and wind. As the water is heated, the pressure of the gas inside the cooker increases. Explain this increase in pressure in terms of particles. As the water is heated, more gas particles is produced. The speed of the particles increases. The collisions becomes more harder and frequently, so the pressure increases. On a sunny day, the temperature of a black tarmac road and the air above the road increases. Explain why the surface temperature of the tarmac increases. The black tarmac absorbs the infrared radiation from the sun, so its surface temperature of course increases. State the method of thermal energy transfer from the tarmac to the air immediately above the road, because they are in contact, so the way is conduction. State the main method of thermal energy transfer from the air immediately above the road to the rest of the air. From the air to the other parts of the air, it is convection or radiation, but it is traveled upward, so it is radiation. Explain why the surface temperature of the tarmac is higher than the surrounding air temperature. This is black, so as we studied black, tarmac is a good observer than the air and a good emitter. As students place the violin near the doorway to a large room. Figure 6.1 shows the young teacher standing where he can hear the sound but cannot see the student. State the wave effect that allows the young teacher to hear sound from the violin at the position he is standing in figure 6.1. The teacher will hear the violin by the diffraction of sound. Calculate the frequency of the sound with the wavelength of 0.75 meters. The speed of sound in air is 340. The equation of speed of sound V equals lambda f. For the frequency equals speed over wavelength. Speed of sound 340 and the wavelength 0.75 equals 453.3 hertz. So we have approximated to two significant figures, comes 450 hertz. A violin produces sound in the frequency range 200 to 3800 hertz. The width of the open door is 0.7. Explain why the young teacher hears the frequency calculated in A2 clearly, but finds a frequency of 3500 hertz is much harder to hear. The frequency calculated here with the wavelength 0.75, which is exactly the width of the doorway. So we will have the maximum diffraction, so can hear this frequency clearly. But as the frequency increases from 400 to reach 3000, the wavelength decreases and it's hard to hear to diffract, and diffraction becomes less. So as the frequency increases, the wavelength decreases and the diffraction become less because of the wavelength becomes less than the width of the doorway. A blind mirror is placed at point X so that the teacher can see the student. On figure 6.1, draw light ray from the violin to point X and from point X to the teacher. Draw and label the mirror, add an arrow to the ray. So here at point X we have a mirror. We need to draw the mirror. For drawing the mirror, we draw the incident ray and refracted ray. Incident ray from the violin to point X, where the mirror is, and its direction. Then we draw the reflected ray from point X to the teacher and with its direction. Now we'll draw the normal, which divides this angle equally. This is the normal. Normal should be perpendicular to the mirror. Now we draw the mirror normal. Have the mirror in this position exactly so the teacher will see the violin. A washing machine has an electric motor and an electric heater. Figure 7.1 shows a simplified circuit diagram for the washing machine. The heater has a resistance of 25 ohm and a power supply has an electromotive force EMF of 230 volts. State the meaning of electromotive force. Electromotive force is the work done by the source to transfer a unit charge around the circuit. State the potential difference across the heater. The potential difference here across the heater is the same as the motor, is the same as the EMF because all of them are in parallel, so it's the same 230 volt. Calculate the current in the heater. Current I equals V over R. V equals 230 and resistance 25 equal 9.2 and the unit ampere. Final answer 9.2 ampere. The current in the motor is 1.6 ampere. Determine the reading on the ammeter in figure 7.1. Explain your answer. The reading on the ammeter is the total current. One of them 9.2 and the other one is 1.6. The sum of them is 10.8. Explanation: the total current is the sum of current in the motor and the heater, which equals I total equals 9.2 for the heater and 1.6 for the motor equals 10.8 ampere. A fisherman uses the frequency sound waves to locate fish in the sea. Figure 8.1 shows the sound waves emitted from the sea. State the name of sound waves which have a frequency greater than 20 kHz. This is more than audible, so this is ultra sound waves. High frequency sound waves travel from the boat through the seawater. The speed of sound in water is 1500 meters per second. The sea bed is 22 meters below the boat. Calculate the time taken for the boat to receive waves from the seabed after the sound is emitted. The distance here is doubled as the sound wave traveled from the boat to the bottom, then back to the boat, so the distance is doubled. D equals 22 times 2 equals 44 meters. So time equals 2D divided by V equals 44 divided by 1500 speed of sound equals 0.029 seconds. The answer is 0.029 seconds. Figure 8.2 shows a fish below the boat. Describe and explain how the reflected sound wave received by the boat from the fish differ from the reflected sound wave received, or the difference between the surface of the fish and surface of the sea. Of course, the fish has smaller surface area than the sea. Smaller fraction of reflected sound will be detected. Question 9. Figure 9.1 shows a wireless charging plate used to charge at the battery in a mobile phone, cell phone. The coil of wire is part of an electric circuit. The charging plate is connected to an AC power supply. The power supply is turned on. Describe the magnetic field around the charging plate in terms of the magnitude and the direction. Okay, the magnitude is constantly charging and greater close to the center. The direction of perpendicular on the plate and so constantly charging. A mobile phone is placed on the charging plate as shown in figure 9.2. The coil in the mobile phone is part of a separate circuit that charges the battery. The coil in the charging plate and the coil in the mobile phone act like a transformer. Explain why this is a current in the secondary coil. Okay, why there is a current? Because the constantly charging in the primary coil induces current in the secondary coil. Suggest why the transformer made from the charging plate and mobile phone is not 100 efficient. Not 100 of course, because some energy is being lost to the surrounding. There is no iron core between them. The mobile phone battery can be recharged using this charger plate and store 4.5 times 10 power 4 joules of energy when fully charged. The current in the secondary coil is 0.63 when the output voltage is 12. Calculate the time taken to fully charge it to completely uncharged battery. As the energy equals VIT, potential difference current times time. So time equals E over VI, energy over potential difference times time. E is 4.5 times 10 power 4, potential difference 12 times the current 0.63 gives you time about 5,952.38 seconds. Answer will be about 6,000 seconds. Calculate the charge passing through the battery in 60 seconds. I, the current, equals Q over T. Charge Q equals I times T. The current 0.63 times the time, which is 60 seconds, equals 37.8 coulomb. Final answer 38 coulomb. Carbon 14, C614, is a radioactive isotope of carbon. Carbon 12, C612, is not radioactive. Explain how the atom of carbon 14, C614, differ from the atom of carbon 12, C612. As you see, here is the number of neutrons. Number of protons is the same, but number of neutrons is different. Carbon 14 have 2 more neutrons than carbon 12. All living organisms contain both carbon 12 atoms and carbon 14 atoms. The ratio of carbon 14 to carbon 12 is 1 to 1 times 10 power 12. Carbon 14 has a half-life of 5,700. When the organism dies, no new carbon is absorbed. The amount of carbon 12 in the dead organism remains fixed. Describe how the amount of carbon 14 in the dead organism decreases with time. The nuclei of carbon 14 are unstable, so they decay by time. Each 5,700 years, the amount of them decreases to half. A sample of what contains carbon 14 to carbon 12 atom to the ratio 1 to 4 times 10 power 12. Calculate how many years ago the 3 dies. As you see here, the ratio becomes 1 to 4. Here is 1 to 1. So it means it decreases to 1 over 4. The ratio changes to its quarter, 1 over 4, which means 2 half-lives. So the time is 2 times 2 half-life equals 2 times 5,700 equals about 11,400 years. Final answer 11,000. Other radioactive isotope has different half-lives. Suggest a use of radioactive isotope with a half-life of 1 hour. Explain why a short half-life is suitable for this use. For a short half-life be suitable to use in medical tracer. Why doesn't it stay in the body for a long time, so it is less harmful. State the name of one planet that has an orbit farther away from the Sun than Venus. Have many planets more than Venus, starting from Earth, Mars, Jupiter, Neptune. So choose any one of them. Let's choose Jupiter. State the name of one planet that has one orbit closer than to the Sun than Venus. Have only one planet, which is Mercury. Venus has an average radius of orbit of 1.1 times 10 power 11 meter and an orbital period of 220 Earth days. Calculate the average orbit speed of Venus. Give your answer in meter per second. Okay, the speed equals distance over time. This distance here is the circumference of the orbit. Circumference of the semicircle is about 2 pi r divided by the time period of the planet equals 2 pi times 1.1 times 10 power 11 divided by the time period of the planet, which is 220 days. We need to convert it to seconds. Times 24 times 60 times 60, 36342.59 meter per second. Final answer 36,000 meter per second. State the relationship between the orbital speed of the planets and their distances from the Sun. As the distance increases, the time period also increases, so the speed of the planet decreases. So the relationship is inversely proportional. Comets are balls of ice and dust. Some comets orbit the Sun. State how the speed of the comet is changing as it orbits the Sun. Explain your answer using ideas about the conservation of energy. You may include a labeled diagram in your answer. Okay, as the comet moves towards the Sun, its gravitational potential energy changes to kinetic energy and its speed increases. The opposite, as the comet moves away from the Sun, its kinetic energy changes to gravitational potential energy and its speed decreases. This is the last question. Thank you.